All right, great. So thanks for keeping up so far. We're going to dip into probably one of the more difficult sections of the curriculum, which is signal routing. This can get very difficult very fast because it's a complicated kind of structure, and it's not a very intuitive subject unless you have like a background in this kind of sort of stuff. For like maybe you're a networking wizard, or like you've been doing a signal flow for video for years or whatever, and a lot of those principles apply. But basically, it's a signal flow is a means of distributing your signal down the line in a means that provides you the most control over every element of your track. And what I mean by that is each of these tracks have an input setting, which is where it's getting signal from. They have modifications, which you can make down the line. They have a send panel where you can send them to other places. And then they have an output patch, which is basically what the end result of the signal, like where it's going to next. As a default, when you open up any project, it's going to have the inputs for your audio channels be like your audio interface or whatever, or for software instruments be like the VST or the plugin or the instrument's actually sourcing its sound from. And then audio effects are all going to be blank, sends are going to be blank, and then the stereo out is going to be its default for the output. So if I click on this, you could actually change it to whatever you want. If you have multiple different outputs in your audio interface, you have those options if you want to send them out to like output hardware and stuff for like, effects returns. And then you have the bus panel, which is the same as the sends panel. It's just basically empty channels, 256 of them, basically, that Logic has made for you to be able to delegate where to send signal to. And then there's the stereo pan, the balance, and the binaural panner, which are basically three means of exporting the sound that you're hearing into your sound system in the room. So if you have more than two speakers in your room, you might want to do like a stereo pan or a binaural panner, because then you could kind of design a 3D space of what you're actually listening to. And that's a very common technique for mixing movies and videos and stuff, is because you need that kind of 3D space to have someone, shout in the back of the room to your right or whatever, but you only have access to left, right, and center when you do it via stereo output. So don't get caught in the weeds with that. We're going to go over the important stuff. So this channel, every other channel that you have down the line is going to have an input, modifiers, or effects, and then a sends panel and an output channel. So your mixer window is probably going to be the easiest way to digest this information. So X will open the mixer window. Great. So let's go to sends first, because normally when you're using kind of peripheral effects or anything, there's a couple different ways that you can use auxiliary channels, which is what we're about to create. The first one is a subgroup. A subgroup is a means of sending all of the signal of a couple tracks to one place that eventually gets sent back to a different channel for you to be able to hear it. So an example of that, if I wanted to change the output of this track to go to bus 10, it's going to create an auxiliary channel for me. And it's going to name it aux2 because it's the second aux channel that I've created. Now, my output of this signal is going to bus 10. The input of this track is bus 10. So anything that's being sent to bus 10 as an output is going to eventually go through this auxiliary channel. And then the output of the auxiliary channel is the stereo output, which is why it's coming out and then back into the program for us to be able to hear it again. That doesn't have to be the case. You could change the output of the auxiliary channel to a different auxiliary channel, and then you could distribute that signal even further. So an example of kind of changing multiple outputs to go to one place is now whatever effects that I want to assign on this bus, or this subgroup rather, will affect both of these tracks that I'm sending it to. So, these first two tracks that I have are going to the output 10, bus 10. I'm putting distortion on bus 10, which is a great idea. And now I'm turning up the drive. And of course, it gets very aggressive very fast because it's distortion. But it's affecting both of these because all of their signal, 100% of their signal, is going through the auxiliary bus before it goes out the stereo output. So a good example of that is not distortion, it's actually compression. So if I wanted to put a compressor on this, this compressor is now modifying the bass synth that we have here and the drum beat, because they're both going to that auxiliary channel. So if I wanted to take the whole signal and compress it, this is what I'm doing now. It's catching everything, right? So that's a subgroup. And the other way to basically distribute signal throughout your project, I'm going to change this back to stereo output, is using a send. So now if I wanted to send a little bit of this signal to bus 10, that's still an option. I'll do it for both here. Now I'll name this, I'll name it reverb. I'll take the compressor off. I'll put space design or something. Let's use chroma verb. Shove it off into the corner for a sec. Now here, this little meter next to the bus on each individual track is a means of deciding how much signal you're actually sending to that place. But notice that the output is still stereo output. So you're getting 100% of the output to go out the stereo output, and you're getting as much signal as you want to go to this other place to get modified. But once it gets modified, it's usually being sent out the stereo output. So it's like a 50-50 distribution. It's like a 50 whatever you want it to be distribution of how much signal you're sending out to get modified and how much signal you're actually hearing. So going back to that like dry-wet ratio that you see on all the plugins, dry-wet over here, dry is how much track is going out the stereo output by itself without being modified, and wet is how much signal you're sending to the place that's actually being modified. So again, it does get a little confusing here, but the sends is a means of distributing signal to a third party to get modified, like an auxiliary channel, before it goes out the stereo output. So let's put both of these at unity. I'm going to use option click here to put both at unity. And now my chroma verb, I'm going to have off to the side here with 100% wet and 0% dry, because I don't want any of the original signal, going through the reverb bus without getting affected by the reverb. That's because all of my original signal is still going out the stereo output. So if I were to send more of that, then it's counterintuitive. You want to be able to send all of it one place and all of it another place at the same time. So I'm going to keep dry at 0. I'm going to keep wet at 100 because I want the entire product of the reverb to be sent out this channel, which conveniently I have access to with one fader. So that'll come in handy later. Actually, I'm going to start with these at 0, and you'll see what happens as I turn them up. So now we're getting a little bit of drum signal into the reverb, but the reason we're still able to hear it is because the reverb eventually goes out the stereo output. So I'll do the same thing with the synth now. So I kind of like the character of this, of what I'm creating, but maybe the reverb is just a little bit too aggressive. I could just take the volume fader and turn it down. So it's taking the entire reverb signal and turning it up or down in decibels, which you have access to with one fader. So if you were to do this, I'll take a chroma verb, I'll put it on this one. I'll take chroma verb and I'll put it on this one. If I wanted to adjust the reverb here, I'd have to open this, make my changes, close it, open this one, make my changes, close it. Say you have 10 tracks in a bus that you want to be able to modify the reverb on. You could do that once instead of 10 times. So it's a massive workflow help. Put this back on the aux channel. And that's just for reverb. Now, any other peripheral effects that you want, just add another send. So I'll make a new send, bus 11. I'll name it delay. So notice here, bus 11 being the output, and bus 11 being the input of the aux channel. So whatever you send to bus 11 will go through this channel with all of its modifications before it goes out the stereo output. And I'll show you one step, maybe 2 steps further on the same idea in just a minute. So I'll take this, send it to 11. I'll add a stereo delay. Keep these, yeah, that looks fine. By the way, Logic's pretty smart. If you add a plugin on an auxiliary track, like I'll put, Space Designer on here, it's going to automatically change the output mix to be 100% wet and 0% dry. It's because the auxiliary channels are designated to be used as peripheral effects. So notice, look, it muted my dry channel as soon as I opened it. If I open Space Designer on here, it's going to give me 100% dry channel, or 0 in this case. So do you see the difference here between the auxiliary effects and using the auxiliary effects on an auxiliary channel and putting the effects on the original track? I hope that is kind of a demonstration of what these channels are actually used for. It's not meant to modify the original sound. It's only meant to add that extra layer of peripheral effects kind of in parallel to what's actually happening, so that you can have the dry and the wet signal on 2 different tracks rather than in the same plugin. So yeah, let's hear what this delay sounds like. There it is. I certainly hear it.